into any topic and any sort of research that you may have to do for that topic.
All right, thank
Just
you.
as long as you as long as you meet the requirements of using at least 2 data structures that you implement, um, yeah, you can do pretty much whatever.
All right,
Uh,
thank you.
I also had another question about my project.
Yeah.
So mine, I wanted to do a password manager, and I was just wondering, like, how resilient to like hardware attacks. I mean, it's all gonna be hardware attacks, but should I really research into like hashing basically everything that's stored in there? Should I make sure that nothing's plain text, anything like
Okay.
that?
Okay. So, uh, for the purposes of demoing this for this class, getting something that's a working demo, not so much necessarily 100% secure, is okay. That said, uh, it's worth noting that hashing and encryption are two very different things. And if you hash a value, you cannot reverse the hash to get the original value.
Yeah, what I was gonna do was I was gonna hash the inputs and store the hash values, and then whenever you put your input in, so all your username and login are saved, and then when you put in a username or login to like get in, it would hash those and compare those to the saved hashes.
There. Okay, so it's using the hash kind of as a key.
Yeah.
All right. So the problem that you're going to have with that is hash collisions, and that we'll talk about when we talk about hash maps and hash functions.
Yeah, I was looking into those. I was using like I already basically made like a simple hashing like program that uses SHA-256. So I'm kind of looking into how I want to deal with collisions. Like if I want to store a linked list, like if I want to do a chained dictionary, if that's even possible. If actually no, wait, dictionaries can only have one input, so I'm gonna have to think about what I want to do with that.
Yeah, they have to have unique keys. We'll talk about that.
Okay.
Wyman, I'm sorry. I have one more
Yeah.
question. So when
Yeah.
we're implementing these, do we use our own interface or the Java interface? Because last night I was doing the Java interface and I got like maybe like all the methods done but two.
Okay, so are we talking about final project or are we talking about
Final project. Like I was trying
okay?
to implement an array list and I was implementing the list from Java and it was like a bunch of random methods. I did most of them, but it was just like some of them where I just like I'm not doing.
Okay, you can use your own interface. I'm using the Java API more as a guide than anything else. A lot of these are stuff that we're not going to get to, honestly, because there's Java started out pretty simple and it kind of ballooned. So there's just too much here, honestly.
Understatement of the decade.
So would you be allowed to use a game engine? Yeah, you can use a game engine. That's fine, as long as you meet the other criteria. You can use any libraries you want.
Oh wait, we can use game engines? Ooh.
Yeah.
So does it have to be in Java then?
Yes, it has to be Java.
Okay, I just want to make sure. Yeah, I can do that.
Any other questions? We do have some stuff to talk about today, and there is a quiz, so I want to get to that.
I do have.
Oh, my bad.
You can go ahead first.
I just had a really quick question about like the group work.
Yeah.
If you're working solo, but like you might have a friend that's also working solo, are you able to like look over their code if they ask you a question or like help them with slight things?
As long as you each are doing your own work, that's fine. I'm not a stickler for, but like when it comes to writing your own data structures and whatnot, there's going to be a lot of not so much copy pasting, but looking at how it's done and recreating it on your own. And there's a certain level of collaboration that does not violate or is not plagiarism. So if you want to talk things out with your classmates, that's fine. Or if you want a second person to look over your code and you want a classmate to do it, that's fine. Ultimately, though, whatever you submit has to be your own. That's the stickler. That's the thing that gets me on this, because so many times in so many classes, I get identical submissions for things, and that's not okay. I generally don't get that for data structures and too much. It's more of a freshman and CS15 problem, but it's just, anyway, long story short, yes, that's fine. Just be sure you do your own work.
Okay, thank you.
So I had a question as well.
Yes.
So this is about the object output stream.
Yes.
So I thought I was trying to figure out how I was trying to mess around with the program, just trying to figure out how it works and everything like that. And I tried to do something like where like doing an assignment, for example. I was just trying to write out a like what I put in for my parameters for like the loan like for the loan file, like saying. And I tried putting that inside like the parameter for write object, for after I created the object output stream, but it didn't really work. And I was wondering, I thought that it would work for any object.
It'll work for any object that implements serializable.
Okay.
So if I go to loan here, that's one thing you need to do. You need to make sure loan implements serializable.
When I was doing that, I had to look up how to do it, and it said java.io.serializable when I implemented it.
Import java.io.serializable. Or
Okay.
alternatively, if you don't have the import, then you don't need the import statement.
Okay.
So that's one thing. Has to implement serializable. Everything here, all the fields have to be either primitive, things that implement serializable, date implement serializable, or transient. And anything that's transient will not be included in what's written.
Yeah.
Yeah. The rest of this, I more or less did this in the, you can review the video if you need to.
I believe the video for this one wasn't there.
The video, let me see.
I'm pretty sure that was Monday's class, and Monday's video is not there.
If you go to lecture, it might not be under lecture. Let me double check here. 2821 lecture.
So lecture, that was the 48 one. Okay.
That was this Monday.
That was let me find it for myself so I don't forget this.
Yeah, so it's under lab 1 files.
So 0448 lecture.
Now I'll double check the other group and make sure I put it in both.
Where would the lecture be at?
Okay, if you go under lab 1 files, 2821 lecture.
Okay. I think I see it.
Right.
Yeah, I see it now. Thank you.
Okay.
Sorry about that.
No worries. Anything else? We do have, actually, if it's questions related to final project, hold on to them, because we do have stuff to talk about today. All right. So let's talk about list. So a couple of things worth mentioning here. So one of the powers one of the things that we get from implementing this iterator method and having a method that returns an iterator is that that allows us to use a for each loop on the collection. You may remember that from last semester. That's a really nice feature because looking at this example here, so create a list, add a bunch of things to the list, and you can see here's a for each loop. I don't need to export it to an array. I can just for string name in names. And that'll do what I want it to do. In order for that to work, the interface, or the class, I should say, the collection class needs to implement iterable. So what I did here is I've got public interface list extends iterable. This is an interface. It's an interface that requires us to implement this method, iterator. And since I have this interface extending this interface, and then this class implementing this interface, this class implements iterable as well, because all my lists here are iterable. Make sense? All right. What we have going on here, again, I have a public default method for iterator, which is just going to return whatever list iterator returns. And list iterator is a very specific type of iterator for lists that has a little bit more functionality than just lists. You can see here I'm actually using iterator and list iterator from java.util. So let's take a look at what list iterator looks like. So you can see Java documentation iterable requires iterator. It's got a default method for split iterator and for each. We're not going to mess with those right now. We might get to them later, but I'm not sure. But it's got a method for iterator, which just returns an iterator. List iterator, you'll recall that an iterator is a class that allows us to traverse our collection. So a list iterator is an iterator for lists that allows the programmer to traverse the list in either direction, modifying the list during iteration and obtain the iterator's current position in the list. So pretty cool stuff here. We've got a list with n elements here, and we've got this notion of a cursor position. So the cursor, each position can potentially have a next and have a previous. So here, next index would return 1, previous index would return 0. Next would return whatever is in that position 1, and previous would return whatever is in that position 0. Now, when we call next, what happens to the cursor? So I call next, it's going to get this element, but then the cursor has to move. It moves on to the next position. So next returns the next element in the list and advances the cursor position. Previous similarly returns the previous element in the list and moves the cursor position backwards. So you can iterate forwards, you can iterate backwards. Here's the trickier parts. We've got set, we've got remove, and we've got add. So set is going to change the value in the list that was last returned by next or previous. So this is going to change the value that was last returned by next or previous. If remove or add was called, then we can't allow set to be called because we don't know what we're setting then. Add. Add is going to insert an element immediately before the element that would be returned by next. So if you call add with an element and then you call next, next should return what was just added.
Could you repeat that real quick? I want to make sure I got that right.
Okay, the element is inserted immediately before the element that would be returned by next, if any, and after the element that would be returned by previous, if any. A new element is inserted before the implicit cursor. So actually I am wrong about that. So a subsequent call to next would be unaffected. Subsequent call to previous would return the new element. Pretty much what it says there. And I actually think I might need to fix my code here.
Okay, thank you.
Let me double check that, because I think I may have fubbed that. So it is going to add that next index, but we need to increment next index. All right, that is fixed. I'll come back to my implementation in just a moment. Remove. Remove removes the last element that was returned by next or previous, which means you can only call remove after you've called next or previous. If next or previous was not called, or add has been called since, illegal state exception. Which means our iterator needs to have some sort of awareness of what the last method was that was called. So in other words, if we call an add method, we can't immediately call a remove method. We can only call remove after a call from next or previous. And if we call a remove method, we can't call a remove method again.
So would you want to have like a Boolean that stores whether a certain function was called or a method was called to keep track of that?
Unfortunately, it's slightly more complicated. That's a good idea. But the issue also is that the remove method is going to behave differently depending on whether next or previous was called. So we've got to keep track of, did we call next? Did we call previous? Or did we call something that prevents those methods from being called? Those methods being remove, set, etc.
And
What
I
would
guess
happen if we removed twice?
Sorry?
What would happen if we did remove twice?
It should throw an illegal state exception.
And what's the reason for it again?
Because we don't know what we're removing the second
Okay.
time.
Thank you.
So remove will always remove the thing that was last returned by next or previous.
Okay, so it's kind of like how nodes work in that sense.
Kinda, yeah. So let's let's take a look at list here. So a lot of this I already talked about. Add method, you need to check the index, make sure it is not less than 0 or greater than size. We can return false or throw an array index out of bounds exception or something along the lines of that. Not array index, just index out of bounds. If we've reached capacity, resize the array. I'm just going to go through this quickly because I've already gone over these. We want to add at a specific position, which requires us to shift values over. So the way we do that, to shift values to the end of the list, start at the end of the list, work your way down to the index, the space that we're trying to free up, and then just move the values down. So list subsize is going to equal list subsize minus 1. So that takes the last value, puts it in list subsize. And then do the same thing with size minus 2 goes into size minus 1, and so on. So all the values just kind of shift over 1. Then list subindex gets the value object, whatever we're adding to the list. Increment size, return true. Add with no index is adding at position size. So add to the last thing in the list. Again, get, check to make sure the index is in range. So if it's less than 0 or greater than or equal to size this time, because size is not a valid index for removing. There's nothing in that position. It's a valid index for adding because it's the next free available space. Make sense?
Yes.
Okay. So if it's not in that range, throw index out of bounds exception. If it is, just return the thing in that position.
So in other words, it kind of works on the restraints of both nodes and arrays. In the sense of arrays, where you have a max size that you have to make sure stays in, and that nodes that we already have to know the addressing in order to refer to the previous one and the next one.
Yeah, I mean, there's still going to be a notion of size for the linked list.
True.
And we're still going to need to reference things by index.
I was just saying, like shift the values down and all stuff like that.
Yeah, it would still throw a new index out of bounds exception. But we're not at linked list yet. We'll do that next week.
That was just an observation I made.
Okay, no, that's fine. All right. Index of needs to find the first occurrence of some object. Again, we talked about this on Wednesday. So I'm not gonna go over this again. Last index of needs to find the last occurrence of the object, does exactly the same thing, but starts at size minus 1 and works down instead of up. List iterator, we will come back to. Remove. Kind of like get and kind of like add. So check the index, make sure that it is in the range if it's not index out of bounds exception. If it is, get the value at that position, and then for loop, int I equals index, I is less than in size minus 1, I plus plus. And what this is going to do is it's going to shift every value, starting with the value directly to the right, or the next value in the array, over 1. So what this does is it's going to clobber the position of the thing we just removed, the things we just got. It's going to replace it with the next value in the list. Do that going all the way through to the end of the array. Make sure that the last entry is set to null, and then return the object. Set, same sort of thing. Make sure index is correct. Get the value in that index, get the old value, update the entry with the new value, and return the old value. Contains. Well, we've got this index of method, which is going to return 0 or positive if the value is in the collection, and -1 if it's not. Check to see if that value is greater than or equal to 0. If it is, then yes, this thing is contained in this collection. If it's not, then it's not. Size, boring. Return size. Clear, also boring. Create a new list.
I have a
and
question
set size to
about
0.
clear.
Yeah.
It's more of a theoretical question. Technically, because you're creating a new list object, wouldn't that mean that the old one is still somewhere in memory still?
No, because Java garbage collection is good.
Okay, yeah, you're right. Thank you.
So yeah. The old one becomes dereferenced. Everything that was inside that list also subsequently becomes dereferenced. If this were C++, we'd have to do a lot more work. Fortunately, it's not C++. All right. Is empty is size equal to 0. To array. Well, for the object, we're just going to make a copy of the list, that array, that is of size. The other toArray method, create a copy of the list of that size. Make sure that you get the class from the array type that is passed into this, and then return the array. Now, this is slightly different from how this is actually implemented in the Java API. And it will behave slightly differently. So the way it's implemented in the Java API is it's actually going to check to see if the size of this array is large enough to hold the collection. And if it is, it will copy the collection into this array. Otherwise, it will create a new array and return that. Either way, it will return an array that contains the objects in this collection. Here, what we're doing is we're just using the array argument to pass the type into the method, so that we can do this getClass method and actually make this method aware of what T actually is. So this is a workaround of the type erasure problem. And then resize array, just create a new array with the new capacity. Let's look at list iterator. All right, so we need to keep track of whether or not next was called, previous was called, or neither. So what we're going to do is we're going to have this int variable called last called, which will initialize to 0, which represents neither next nor previous was called. And every time we call next or previous, we're going to update last called to be either next or previous. And then every time we call add or remove, we're going to check the value in last called so we can determine how this should behave. We're also going to keep track of the cursor position by having a variable called next index, which indicates what position is immediately after the cursor. Has next is going to just check to see, is next index strictly less than size? Has previous is going to check to see if has next or next index is strictly greater than 0. So if next index is 0, that means we're at the start of the list. There's nothing before that. Next will return the first element in the list. Previous should throw an exception. Next, check to see if has next. If not has next, throw out no such element exception. Otherwise, last called equals next. So set that flag to say we've called next. We are going to return what is in the list at next index, and then increment next index. Previous, very similarly. If it does not have previous, no such element exception. Otherwise, last called equals previous. And we're going to return what is in the list at next index minus 1, and subtract 1 from next index. Next index returns next index. Previous index returns next index minus 1. Remove. All right, so remove is going to check to see if last called equals previous. Well, if last called equals previous, think about what previous does. Previous decrements next index and then returns the thing that's in that value, that position, right? So we've decremented next index. Next index now is the index of the thing that was returned by previous. I know what I just said. I know how weird that sounds. But the reason that's the case is because if we just called previous, we just moved that cursor back, which means a call to previous followed by a call to next should return the same value, the same thing in the list. Does that make sense?
And that's because you moved the pointer backwards, right?
Exactly. So calling previous is going to get the thing that's before the cursor and return that, but it's also going to move that cursor back. So next index is now the index of that thing that was just returned by previous.
Was previous a reference? Or,
Previous is a function, and then next index is the thing that that returns the thing before the cursor.
Oh, okay.
But it also moves the cursor back one.
Got it.
So since the cursor's been moved back one, next index is now the index of that thing we just returned. Which means if we called previous, we're going to remove the thing that's in that current position. So remove the thing that's at next index. If we called next, that means we're removing the thing just before that next index cursor. So the way we would do that is we would subtract 1 from next index, remove the thing in that position, and now another call to next should return the next thing in the list. If we did not call next or previous, throw in a legal state exception. Remove called without next or previous. And finally, before we exit this method, last called initialized to 0. We do not want repeated removes. Set. All right, so set if last called was previous, then the thing that was last returned was the thing in next index. We're just going to change that thing to be whatever we're passing to it. Not removing anything, not adding anything. This is pretty straightforward. If last called was next, then the thing just before next index is the thing we're updating. Because that was the last thing returned by next. Else, a legal state exception. We don't necessarily need to reset the flag for last called here, because we didn't, a subsequent call to set would just overwrite the previous set. We just didn't move the cursor. So there's not much confusion by what subsequent calls to set would do. Add. So add is going to insert before next, and it's going to have to move next index so that a subsequent call to next would return whatever the next value would be. So we are inserting a value at that cursor. So if I go back to here, suppose we are here, we're inserting a value right here, but next should still return this. Previous would then return whatever we just added to the collection. So in order to do that, we're adding at this index. We are incrementing the value. That's pretty much it. And we just make use of the add method for the list. There's our list iterator. I can show you how all this works with simple driver here. It's not complete, but it'll give you an idea. Let me just run this. Just run it in the thing here. So you can see we added all those names. Added Bob twice. Index of Bob should be 1. Last index of Bob should be 5, and so Testing list iterator going forwards gives us all the values in that order. Going backwards, so that would give us all the values in reverse. Then next would be Alice. Next would be Carol. If you try to remove at this point, remove would remove Carol. Previous should return Alice. And then for each of the collection shows you Alice, David, Eve, and Bob. Carol was in fact removed from the list. To show you how this works, or what this looks like in code, let me drag the terminal back down here. Working with a list iterator, create a new list iterator object by calling list iterator method. And then we can do things like while it.hasNext, print out it.next, or do whatever we're going to do with it. If we want to go backwards while it.hasPrevious, we can print out or do whatever with it.previous. Or you could do these one at a time. Next returns Alice, next returns Carol. So this takes the cursor from the beginning to the end of the collection. This takes the cursor back from the end to the beginning of the collection. And then we just call next again to get individually one at a time. And then if we remove in this case would remove what came from next. And if I try to call remove again, that should throw an exception. Actually, that probably won't throw an exception because I called it.previous. So you can see how that would work. Let me run this. And there we go. So yeah, removed Alice that time because I called previous already. So that seems to be working.
So this is a little bit off topic. I just remembered a question. This is about the lab. Did you want us to prompt the users to update the file if they want to create a new one after you create a file?
Okay, so the lab, if the file does not exist, creates the file with one lone object. If the file does exist, it's going to overwrite that file. It does not update it. It just clobbers it.
What do you mean by overwrite it? Like we did prompt the user.
Overwrites it. It just, if you try to write to the file using the methods we've talked about, this file is going to be overwritten. The contents of it are gone.
Yeah, I'm just asking if you want us to do that for.
Yes.
Okay, thank you.
All right.
Just one quick question.
Yeah.
Could you go to list iterator real quick? I didn't quite get all the bits of the code down.
Yes.
Let me see here. It was like just right under. That's the one I missed. Okay.
Can you post that to Canvas at some point?
I will decide that over the weekend because I'm not sure if the lab's going to be to recreate this. At the very least, I will post this and this.
Okay, that's totally understandable. Thank you.
All right, thank you.
All right.
So I assume that's our quiz then? Well,
yeah.
Our quiz is next then? So yeah.
So I will let you go now so you have time to take the quiz. Stay safe and healthy, and I'll see you on Monday.
All right, thank you.